in problem number 3, it says a point moves on the x-axis such that its velocity at time t, so this is important here, t is greater than 0, is given by this. So this is like some equation. Just to make note here, it says v equals this. It could also have been written v of t equals ln of t over t. Notice I put parentheses around the ln. It's implied. In other words, i.e. it's always there. Okay? Just as x squared, there's a parentheses around the x here. At what value of t does v attain its maximum? So v in max. So if you remember on the last problem, max means, or min means I take the derivative and set it equal to 0. Okay? A derivative of what? This is important because it could be, we need to know what we need to find the max of. We need to find the max of v. So we're going to take the derivative of v and set it equal to 0. This is not always the case, so you need to read the problem carefully. So we're going to do so. So we know v is equal to ln of t over t, right? So I'm going to take the derivative of this one with respect to t. Why t? Because this is a function of t here. So I'm going to go d dt at both sides. So what do I get here? You could write dv dt, it doesn't matter. So dv dt, we're going to set it to 0 in a second, equals, we're going to use the quotient rule here because it's a function of t, the numerator and denominator. So low times d high minus high times d low, d, remember because you're taking it with respect to t, d low of t all over low. Okay, t squared. And then we just simplify. And remember, you're going to take the derivative and set it to 0. So basically, you can just, if you want to right now, you can just call this 0. It doesn't really matter. So you're going to get t times the derivative of ln. If you remember, d dx of ln of x is just 1 over x. This is just like background knowledge we should have by now. Times, so this is times. This gives us 1 over t, that was the derivative, minus ln of t stays the same, times the derivative of t with respect to t is dt dt, which is 1 all over t squared. And remember, now I'm just going to go ahead and set it to 0. Okay? So we get 0 equals t over t is 1, right? The t's cancel out. However you want to do that, doesn't matter. So you just get 1 minus ln of t times 1 is just the natural log of t all over t squared. Now you need to think back to the definition here. So if you remember the first derivative test, it basically says like, okay, so I need to find the values for when the derivative is 0 or undefined, right? So I need to know where, in this case, v prime is 0 or v prime does not exist. In this case, you can see here, we need to find the t values for which that is true, right? So I know that if t equals 0, then v prime does not exist. So I want to be really clear here. T equals 0 is a critical value, and it could be an extreme value. However, because it's not in the domain of the function here, see, t has to be bigger than 0. And I said, I found one number that could be a suspect, but we don't have to worry about it because it's not in the domain of what we're talking about. So, we can, this one, we've already accounted for this one. We found that, but it's not in the domain, so we don't need to worry about this piece here, okay? So this is done. We found that one, but that's not what we're concerned with. So we're just going to continue to solve this here. So I'm going to multiply by t squared to both sides. T squareds cancel out. And t squared times 0 is 0. Okay? And now I'm going to solve L for 1 minus the natural log of t. I'm going to minus 1. And then I get, this is going to be negative 1 equals the negative natural log of t. Divide by negative 1. So I get 1 equals the natural log of t. I'm going to transpose. That means that's the base to the answer is the middle. So the base is little e. So it becomes, let me rewrite this actually. Some people like to see it like this. So little e becomes big E base to the answer was 1, equals the middle component, which was t. So t just equals e to the 1, which is just t equals e, is the answer. So this is an extreme value. So note, we don't know if it's a max or min. However, the problem explicitly tells us that it's a maximum. So we don't need to do any testing. We already know what it is, and the answer is C.